Hey guys, we need to talk about relations and functions today. A relation, not talking about your friendships and your family. What we're talking about in math is a relation means a pairing of input and output values. So if you look here, this right here is called a mapping diagram. And basically what it's doing is it's telling you what number belongs to another number. So if we look, here's our input values. And if we have a 0, that means the 0 could either go to the 1 or it could go to the 3. If we have a 2, the 2 automatically goes to the 3. If we have a 3, it could go to the 3 or the 9. And if we have a 4, it could go to the 7. We could look at this actually a couple different ways. So this could be a table. And so we have our input values, which are usually x values, and our output values, which are usually y values. And so we have that first arrow gives us that 0 for the x value is a 1 for the y value. But we could also have 0 and 3. So I'm just following the arrows. I could have 2 and 3. Going down to the next input, see our input of 3, it's either the 3 or the 9. So I need to put both of those on my table. So we have 3 and 3, 3 and 9, and then the last one is 4 and 7. So I could write that as a table, or I could go ahead and I can write that as ordered pairs. So the 0, 1 I can write as 0, comma 1. And then I can write 0, comma 3. And 2, comma 3, and 3, comma 3. So it looks a lot like the table, and typically we actually write them horizontally, so it would be 0, comma 1, comma, and then the next one 0, comma 3, comma, and 2, comma 3, comma, 3, comma 3. And let's finish this off. We have 3, comma 9, and 4, comma 7. All right. And we even enclose them with squiggly brackets, and there's our set, and so we call that our relation. So again, a relation is just when you're putting x and y's together. Now, some of our vocabulary, we have down here domain. Domain is our input values. So you'll see that right there, input values or our x values. It's that collection of those. So if we go back and look at our mapping diagram, all of these right here are part of our domain. So the domain for this example would be 0, 2, 3, and 4. That collection of numbers is our domain. Range, on the other hand, is what they go to, the outcome, the output. And so the collection of output values would be 1, 3, 7, and 9. All right. Domain, where you start. Range is where you end. Now, a special term in math that we're going to see a lot, that we talk about a lot, is this word function. So if we look at the definition of relation where each input goes to only one output. Okay, let's try and make more sense of that. When you have an x value, that's your input. There's only one possible output. So there's a couple ways I like to talk about this. We could say that we could be doing a cheer. You know, we have cheerleaders, and so maybe cheerleaders. Remember that cheer that says, when I say Winnie Mac, you say Patriots. Winnie Mac, Patriots. Winnie Mac, Patriots. Wouldn't it be confusing if in that cheer they could say Winnie Mac and you could say Patriots, or I don't know, what was it? Macintosh was a Scots, right? So Patriots or Scots, and so then all of a sudden you have a crowd saying, some are saying Patriots, some are saying Scots, and that would be confusing. So that would not be a function. A function is when you know exactly what's coming next. So if we look at this example above, this is not a function, and the reason is when I say 0, you could say 1 or you could say 3. That's too confusing. We can't do that. Another way of talking about functions is to say the input is letters or mail. The output would be the mailbox. Now, when I say mail, I mean an actual letter that is going somewhere. So if I'm talking about this mail 0, so let's say that piece of mail is 0. According to this diagram, it needs to go both in mailbox 1 and mailbox 3. It's like having two different addresses in the mail. You can't put it in both. It's illegal, actually, to tear up a letter and put it in two different ones. So only if this works is it a function. because it's going to two different mailboxes, it is not a function. The 2, however, was okay, but the fact is that you actually have 2 times that this doesn't work. The 0 and the 3 both go to 2 different mailboxes. And so this is not okay, this is not a function. Only if every single piece of mail goes to a single mailbox is it a function. So let's look at some other examples. Let's see here. I'm going to change my color, I think. Go to white. And for example, I could give you this problem. 1, 2, 4, 7, 5, 3, and 3, 2. So the question is that a function? I like to use a mapping diagram to help me decide if it's a function. And the idea of a mapping diagram is you make your 2 bubbles. You put all of your x values in the first bubble. So we've got 1, 3, 4, and 5. You put all your y values in the second bubble, 2, 3, and 7. Now you'll notice 2 happens twice. It happens there and it happens there, but I'm only going to write it once in that other bubble. And now I map it out. According to the very first one, 1 goes to 2. So I draw my arrow 1 to 2. And the next one, 4 goes to 7, 5 goes to 3, and 3 goes to 2. So the question is it a function? Now remember, for every input, so for each one of these inputs, you can only go to 1 output. So 1 goes to 2. It only goes to 2, so we're good. 3 goes to 2. It only goes to 2, we're good. 4 goes to 7, and 5 goes to 3. So we're actually good. This is a function. And I know some people get confused because they say, well, there's 2 different things going to 2. Let's go back to the mailbox example. This is a letter and this is a letter. Can you have 2 different letters go into the same mailbox? Absolutely. I get many letters in my mailbox every day. And so that's still legal. This is a function. If we're looking at the cheerleaders, when I say 1, you would say 2. When I say 3, you would say 2. When I say 4, you would say 7. When I say 5, you would say 3. It's all good. So these are, this would be considered another function. Alright, so we've actually already done this. It says you can represent a relation or function using ordered pairs, x, y, and we've already done make a list of those. And the last thing I'm going to talk about is this vertical line test business. You can use, if you don't have it listed out in a table or as ordered pairs, you might have a graph, and then you could actually use the vertical line. Now you can take some time and look at the example on page 68, example 3, but I'm just going to talk about this a little bit here. So let's say we have a graph of something. Oh, I don't know, let's say the graph looks like this. Well, remember, for every x value, you can only have 1 y value. So think of this x value right here. If we follow it up, we see that it goes right there, and it has only 1 y value. There's no other y values. It's not like it's up here or down here. Okay, and no matter where I go, I only have 1 x value. Now, one way to tell that is the vertical line test. If you can put a vertical line anywhere on your graph, and it only goes through once, it is a function. So if I drew, let's say, a sideways parabola, this would not be a function, because if I drew a vertical line, we actually have 2 spots where this touches the graph, right there and right there. So because it hits it twice, think about x and y. Here's my x value, I have a y value here, and I have a y value here. I have 2 different y values, and that's a problem. So the vertical line test, if it passes the vertical line test, like it did on this first one, where you could put vertical lines anywhere on the graph, then you have a function. If it doesn't pass the vertical line test, like on the second one, then it's not a function.